Hi everyone, in this video we are going to discuss bases. The main objective of this video is we're going to try to distinguish the difference between a strong and a weak base. But in order to do that properly, we absolutely need a quality definition of a base. And so we're going to use a definition that's very similar to the definition we presented for an acid, but instead of an H plus ion, we're going to say an OH minus ion. So for a base, it is simply a compound that releases OH minus ions in aqueous solutions. So it is literally the exact same thing as an acid, except for instead of releasing hydronium ions, we actually release what are called hydroxide ions. So that's the difference between an acid and a base. So how do you know if you're interacting with a base? Well, if you taste it, it's going to taste incredibly bitter. Okay, really, really bitter. It's not good. It's a terrible taste. You don't want it. If you feel it, so if you're in lab and you interact with base, it's going to feel very, very soapy. It's a really gross feeling because what's actually happening is the base is dissolving the fat on your fingers, and so it actually, you can feel like that soapy, nasty, it's disgusting. It grosses me out whenever I get base on my hand. Ugh, I don't want to think about it. Okay, and then a big thing I want to just add here, most people think that milk is a base. Milk is not a base, so I'm just going to write in here, not milk, and we're going to talk about that in future videos, but that is one of the biggest misconceptions I get all the time, and milk is not a base. Technically, it's an acid, but we'll get there later. All right, so now, how do you know if you're actually interacting with a base? What is the ion? What are you looking for? Well, in a microscopic level, we're looking for the hydroxide ion. Okay, so the hydroxide ion is just OH and it has a -1 charge. So if you ever see a hydroxide ion, it indicates that you're dealing with a base, or there's a base somewhere in your reaction, or something to do with a base, okay? OH minus means base. So now we said we're trying to distinguish strong from weak. So the first thing we're going to do is identify our major strong bases. So for a strong base, or strong bases, they are simply a base that completely dissociates in H2O. Completely dissociates. So now there's three that I expect you to know. The first one is KOH, the second one is NaOH, and the last one is BaOH2. So we're going to go through each one individually. The first one is potassium hydroxide. If you ever see potassium hydroxide, I want you to immediately think base, 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 base. I'm dealing with a base, okay? Then you have sodium hydroxide, or NaOH. Sodium hydroxide is very common, okay? And then the last one is barium hydroxide. These three, I expect you to know, are strong bases, okay? They're strong. They're fully going to dissociate in water. So let's go through each one of them. KOH. If you interact it with water, it's going to fully dissociate, meaning you're going to completely break up into the cations and your anions, and then immediately you see that hydroxide, and so automatically, if you didn't let the KOH register, you would immediately see the OH minus and be like, oh, there's a base, somehow we're dealing with a base. Next one, NaOH, sodium hydroxide. Sodium hydroxide, if you put it in water, will break apart into sodium plus and OH minus. Fun fact, if you ever have a really, really good quality pretzel, they probably actually use sodium hydroxide instead of baking soda in order to create that, which is kind of cool. I love making pretzels. It's fun for me. I've never actually done it with sodium hydroxide before, but I think that would be really cool. All right. Last one, barium hydroxide, very, very strong base, so you need to make sure you separate it. So the first thing we need to indicate here is if you ever see OH2, make sure you balance that equation. We have 2 hydroxide ions, all right? So it's Ba plus 2 hydroxides. These are your 3 strong bases. Everything else is going to be considered a weak base. Everything else. So if it's not one of those 3, it's considered a weak base. So a weak base, just like with a weak acid, is a base that remains partially intact in water. Okay, these are always in water. If we change the solvent to benzene, toluene, DCM, something like that, it's not going to work. They're going to have completely different properties. So, for example, one of our most common weak bases is ammonia. We see this all the time. It's used in cleaning supplies, but ammonia is one of the best bases that we see, and it's very common. And so what happens when you put ammonia in water, something really neat happens. So your NH3 ends up actually stealing one of the hydrogens that are on water, and you end up getting your ammonium ion, which is another polyatomic ion. So hopefully you already know this one, ammonium ion. All right, so that happens. So you steal one of the hydrogens in water, which means if you look at water, if one of these went with the ammonia, that means all you're left with is OH. And so you end up with your OH minus. Ding, ding, ding. Hydroxide, definitely looking at a base. Okay, so this is what happens for a weak base. It's a lot easier to tell when you're dealing with weak bases than it is with weak acids, but that's just my personal opinion. All right, last question here. What is the name of OH minus? Go. All right, did you get an answer? Hopefully you did, because I just said it, but if you didn't, that's okay. OH minus is definitely your hydroxide ion. So from here on out, if you ever see OH minus, you are thinking, oh my goodness, I am definitely dealing with a base. All right, that's it for today. Take care of yourself and do not drink bases.